Hi, I'm Todd with the Land of Math. In this video, we're going to spend a little time looking at the hexagon. It's become very popular lately with businesses and also designers. So we're going to look at a little bit of the math behind the shape and what has made it become so popular recently. So all that's coming up next on the Land of Math.
So what is the deal with the hexagon? How has it become so popular? You see it everywhere. Huntington Bank, for example, has a part of their logo, and they even use it like on chairs and on glass inside their bank. A variety of different crypto companies use it. Be Clean Car Wash in our local area uses it. Dunham Sporting Goods used hexagons in an ad recently. The NAA magazine I got the other day, one of the ads used a whole bunch of hexagons. Different lights that you might want to use around your house use hexagons. The hex nut on a bolt, obviously it's a hexagon. All sorts of different types of flooring uses hexagon. Even the bees around this in their hive. When we designed our grade 8 book for the cover, we used hexagons. So why the hexagon? It's all about the angles. So regular polygons, we know all the size angles are the same. And there's basically just three of them. There's the triangle, there's the square, and there's the hexagon. So let's look at the square first. So when we're looking at the square, and it shares some same properties with the rectangle, so we'll include both here, even though technically a rectangle is not a regular polygon, you notice that they have 90-degree angles. And so this is going to be important. So if you take your 360 degrees and you divide it by that 90 degrees, and we'll explain a little bit more about the 360 and why it's important here in a second. But if you take 360 and you divide it by 90, you get a whole number, in this case 4. If we look at the triangle, an equilateral triangle, the angle is going to be 60 degrees. If you take 360 and you divide it by 60 degrees, you're also going to get a whole number. You're going to avoid a decimal. So in this case, 360 divided by 60 is going to be 6. And it's the same thing when we get to the hexagon. When we're looking at the hexagon, each angle of a hexagon, the interior angles, are going to be 120 degrees. So if we take 360 degrees and we divide it by, in this case, 120, we end up with 3. And again, it's a whole number, and so we avoid the decimal. So why is the 360 degrees such a big deal? These shapes we can tile. And so if you notice here, they're all going to fit together nicely. So if we look at a bunch of the squares, if we put all the right angles together, so all the 90 degrees together, when we add them up, there's 4 of them, and it's going to equal 360 degrees. So if you take 90 times 4, because you can see there's 4 shapes that came together, it equals 360 degrees. The same with the triangles. If you put all the triangles together, you see there's going to be a total of 6 triangles that go together. And if we look at all the arcs, it's going to make a circle. So if we took 60 and we multiply that by 6, that's going to give us 360 degrees exactly. It's the same thing down here with the hexagon. If we're looking at the hexagon, you can see that how these shapes fit together nicely. So they tile, or there's a pattern. We have 120 degrees each angle. When we put the angles together, 120 plus 120 plus 120, that's going to equal 360 degrees. So all those arcs together, when we add them up, equal 360. So you can see 120 times 3 is going to be 360 degrees. Now, the rectangle is going to have the same properties as the rectangle, or the squares. So you can see here, for example, we have a whole bunch of hexagons, and they're kind of all just tiling together. So they're all connected. And that's because every time 3 hexagons come together, they're going to equal, the angles will equal 360 degrees, and they'll all fit together nice and easy. There's a nice connection between them. So let's look at a couple shapes that are well known, the pentagon and the octagon, but they're really not used very often. So when we look at the pentagon, we'll notice that the angle of a pentagon equals 108 degrees. So when we go to put our pentagons together, each of the angles that are kind of connecting here are each going to be 108 degrees. But we have a problem. It's not going to go into 360 evenly. If we take 360, which is what all these angles should equal, and we divide it by 3, we divide it by 108, we end up getting 3.3 and the 3 repeats. So what that means is We need 3 shapes, 3 pentagons, which you can see, but you can see we need this additional wedge. So the pentagon, when you put together, does not tile together evenly. The same thing happens with the octagon. If you look at an angle of an octagon, it equals 135 degrees. So when you go to put your octagons together and try to have that common point that they all share, you have to put all these 135 degrees together. And you can see it doesn't work here. If you take 360 and you divide it by 135, what you end up getting is 2.6, and that repeats. You could also think of it as a fraction 2 and 2/3. But basically what it means is you could put 2 octagons together like the red and yellow, but when you put the third one together, they don't fit. You can see there's this overlap right here. And so this shape, the octagon, doesn't tile. Much like the pentagon, even though they're well known, we don't really use them like in the business world. So what's the bottom line? Why is it so popular? First of all, the regular hexagon can tile. Only triangle and squares can do that. The regular hexagon is the largest of the regular polygons. Regular hexagon is the closest shape to a circle, so it has the greatest internal area, and designers and companies like the symbolism of a network of interconnectedness. So hopefully it was helpful. Until next time, we'll see you on the Land of Math.